Okay, so getting into the third part of this chapter, we're going to be kind of going back to graphing a little bit to get us started, but we're going to be talking about inequalities. Do you guys know what an inequality is, like what that word is talking about? Instead of an equal sign, there's something else instead. Greater than, less than, greater than or less than, or like greater than or equal to, less than or equal to, something like that. You're going to have some of those symbols. And so when we're talking about, we'll eventually get into solving quadratic inequalities, you're going to still graph them like we did back at the very beginning of this chapter when we were in part 1. But we're going to talk also about, like, since it's an inequality, that means that there's not just one solution or two solutions. There's a whole set of solutions that would work because you have greater than or less than. So it doesn't need to equal exactly these two numbers. It could be anything less than 2. So wherever 2 is, it could be anything smaller than that. So like if you think about your number line, 2, anything smaller than 2 would be like 1, 0, -1, -2, -3, -4, and so on. So when we talk about these, we'll do a little bit of like shading, which we've done linear inequalities in the past. So you guys probably learned how to graph and solve like a linear inequality in Algebra 1. So we're actually going to start with that first, just to kind of review how you handle a linear one, because those same rules apply to a quadratic. So remember that linear equations are usually in this form, y equals mx plus b. That's that slope-intercept form. So you graph the y-intercept, you start at your b, so you go up or down a certain amount of numbers, whether it's positive or negative, and then you use your slope. Slope is that rise over run. If it's not a fraction, so if it's a whole number like 5, put it over 1 so you can see the rise over the run. But if it already is a fraction like a half, 2/3, or something like that, then you don't have to write your slope as a fraction. It's already done, so you can already see how much you go up or down, left or right to graph a new point. Okay, so let's take a look at this first one. We've got y equals 2x plus 3. So if I wanted to graph this, remember this is mx plus b. We start at the b number, which is the plus 3. So from 0, 0, you guys are going to go up 1, 2, 3. What's the slope of this line? 2 over 1, if you wanted to look at the rise over the run. So from that point, 3, you guys are going to go up 2 and right 1 because it's positive. So up 2, right 1. If you're running out of room and you still want a couple more points, you could always go the opposite direction. So because I went up 2, right 1, I could go down 2, left 1 instead. You don't have to do that, but that is helpful to know if you're graphing something. And a lot of times, like, I'll see students draw a graph and then they get their first point and then they realize, oh, if I try to go the directions I need to, I'm running out of room. And then they want to erase and start over. Instead of having to erase, just go the opposite direction if you've got room that way instead. Okay, but so once you've got those points, go ahead and draw your straight line. If you've got like your lunch card or a card from just like your wallet, those work really well as like a makeshift ruler for you, so you don't have to have a ruler to do this. Okay, so now let's take it one step further and look at an example that's dealing with an inequality instead. So remember, inequalities mean less than, greater than, less than equal to, greater than or equal to. In order to graph an inequality, when we're talking about just a linear inequality, you graph the line just like we did before. Have it be in slope-intercept form, y equals mx plus b. Start with your y-intercept. Use your slope to find more points for your line. But before you go and you draw your line, you have to check a couple things. Figure out first, is your line going to be a solid line or is it going to be a dotted line? So it's solid if the inequality sign has an equal sign with it. So if you have less than equal to or greater than equal to, it's going to be a regular solid line, because that means that points on that line could also work as solutions. If it doesn't have an equal sign, then you have to have it be a dashed or a dotted line, because that means that the solutions are not included on the physical line. Then we talk about shading, because like inequalities, like I said before, means that there's more than just one solution or one set of numbers at work. There's a whole bunch, and they could be greater than or less than. So if you have greater than or equal to, you shade above the line, and less than or less than equal to, you shade below the line. When I talk about shading, you're just going to kind of color that side of the graph. You can use your pencil, you can use a colored pen, a highlighter, I don't care. You just have to be able to show me somehow where are the solutions at. Let me see that shading somewhere. Okay, so let's take a look at one. I've got y equals 1/3 x minus 4. So I'm going to start by graphing this, just like I graphed my previous one. So it's already in slope-intercept form. Right now, don't worry about the inequality sign. So the minus 4 is where you guys start. So from 0, 0, you go down 4. And that's your first point. Now your slope is 1/3. Do you guys know what directions you're going to have to go? Good. Up 1, right 3. You can do this as many times as you want, like make those points. You only need 2 to form a line. That way you can see where it goes. If you want to do more, if you want to fill up your graph as much as you can, that's fine. So if you wanted to, you could always go down 1 and left 3 a couple times to get some more points. You don't have to do that, but you sure can. Now we look at our inequality sign. So it's a greater than sign. There is no equal sign for this one. So it's not a solid line, it is a dashed line. If you want to, you can always still draw a solid line and then go back in and just kind of erase some portions of your line so that it looks dotted now. Now greater than, if we go back up to our shading rules, that means that we shade above the line. Okay, above the line for this one is going to be up here. So I'm just going to kind of color in this area of my graph. This lets the person know that any point up in that shaded area that I colored in that green, any point that I picked up there, if I plugged it into this inequality, it would be true. If I put in the x and I put in the y from that coordinate and I simplified it, I should get a true statement. All right, let's take a look at this next one. So right off the bat, I notice that this one is not in slope-intercept form right away. It doesn't have y and like your inequality sign mx plus b. So we're going to have to first rewrite this a little bit to get y by itself. So think about when you were solving equations and you're trying to get one letter all by itself, you got to move everything else away from it. So the first thing I need to move is that 3x. How am I going to move that 3x? Good, subtract it. So I'm going to have 2y less than, and we always put the x first because it's mx plus b. So negative 3x and then plus 6. How do I get rid of that 2? Good, divide by 2. And make sure you guys divide every term by 2. So you do the y divided by 2, the negative 3x divide by 2, the 6 divide by 2. So then I have y less than. I'm going to go ahead and write this as a fraction, so it's negative 3/2, and then I'm just going to stick x next to it. It doesn't really matter where x goes. What would be 6 divided by 2? 3, so we have plus 3 there. So here's our equation that we're going to graph. So where do I start at? I wanted to graph this, where would I begin? 3. So I go up 1, 2, 3. How do I use my slope? Good. Down 3, right 2. Or you could go up 3, left 2. One of those numbers, 3 or 2, has to be negative. Not both, just one of them. That way your line is going to go down over time because this is a negative slope. Is my line going to be solid or dashed? Good, dashed, because I have a less than sign, no equal sign involved. Okay, now less than means I need to shade below the line. So below the line for this one is going to be over here. All right, on the next page, we've got 2 times x minus y greater than or equal to 5. What would you guys do first? Like, what's your first? Yeah, to distribute probably. So if we're going to take 2 and distribute inside, it's now going to say 2x minus 2y greater than or equal to 5. Then what would you do? Okay, subtract 2x. So you've got negative 2y greater than or equal to negative 2x plus 5. What's the last thing we need to do? And again, make sure you do that to everything. Okay, does anybody know there's something that's got to happen here? Because I'm dividing by a negative 2. When you divide by a negative or you multiply by a negative and you're dealing with an inequality, you have to switch the sign. You have to flip it to the other direction. So right now it says greater than or equal to, but because I'm dividing by a negative 2, it causes this sign to become less than or equal to. So make sure that if you divide or multiply by negative that you switch that sign, or else when you go to shade, you'll shade on the wrong side of the line. So negative 2 divided by negative 2 is 1, so we have 1x or just x. And then I'm going to go ahead and write this as minus 5 over 2. Okay, so when I go to graph this one, my b is a fraction, okay, 5 over 2. So what would be 5 over 2 as a decimal? 2.5. So when you guys graph it, you have to go to negative 2.5. So you have to kind of estimate where that's at. So you're going to go down 2 and then go down half. So it's right in between negative 2 and negative 3. Now slope, the number in front of your x is a 1. So technically the slope is 1 over 1 to do your rise and your run. So from that point you're going to go up 1, so you're still in the middle of a square, and over to the right 1. And you can do that as many times as you want to until you start to see your line. Is this line going to be solid or dashed? Solid, because it's got an equal sign with the inequality. Now it's less than this line. So less than, for this one, that would be like underneath it. So it'd be kind of off to the right side of that line. Be anything that's smaller.